Hi, I'm Raj Vijay Singh. I welcome you all to Mathscriber. In this video, I'm going to discuss about some product identities. Before we start, as usual, I must say, if you're fond of learning advanced math stuff, please click like and subscribe. To get to know about my live classes, visit mathscriber.com. So here we go. Let's get started. In a previous video, we learned about sum difference identities. Now let's see first of all, what are these sum difference identities? We learned sin A plus B is sin A cos B plus cos A sin B, and sin A minus B equals sin A cos B minus cos A sin B. Now we name this 1 and we name this 2, and if you don't remember this stuff, I'll put a link above. It will guide you to the previous video that I discussed about this sum difference identities. Now we are going to derive our sum product identities using these two, and we are going to derive two sum product identities using those two equations. Later on, we'll use cos A plus B and cos A minus B and derive other two sum product identities. Now we'll add 1 and 2. Now when you add this right side, if you notice, now we have sin A cos B and we have sin A cos B. Sin A cos B plus sin A cos B will be 2 sin A cos B equal, in our left hand side we are adding these two, so it's basically sin A plus B plus sin A minus B. Sin A plus B plus sin A minus B. So here we go. This is our first sum product identities. Okay, now we'll subtract 2 from 1. Then what we will get? We'll get, now when you are subtracting sin A cos B minus sin A cos B, it will vanish, so it will subtract each other. But when you subtract cos A sin B from this, when you subtract minus cos A sin B from cos A sin B, so cos A sin B minus cos A sin B, so it will be, now it is basically cos A sin B subtract minus cos A sin B, so minus to minus will become plus, so this will become 2 cos A sin B. What happened was cos A sin B minus cos A sin B, minus to minus plus, so these will get added, and it is cos A sin B plus cos A sin B, which is 2 cos A sin B equal. Now we are subtracting, so these two, the left hand side which we are writing on our right hand side, we swap the sides. Now it will be sin A plus B minus sin A minus B. Here we go. This is our second sum product identity. Now let's see, using this cos A plus B and cos A minus B to derive our other two sum product identities. Now let's consider cos A plus B and cos A minus B. In the previous lesson we learned that cos A plus B is cos A cos B minus sin A sin B, and let's name these 3 since we named previous equations 1 and 2, and cos A minus B equal cos A cos B plus sin A sin B. and let's name this equation 4. Now we'll be adding this 3 and 4. Then you get, first of all we'll be writing the right hand side in our left hand side, then we'll add this right hand side. Okay, now right hand side we have cos A cos B and we have cos A cos B. When you add these two, it will be 2 cos A cos B and minus sin A sin B plus sin A sin B. These will get cancelled off, so there won't be anything except this 2 cos A cos B equal. Now we are adding these two, we just write it is cos A plus B plus cos A minus B. So this is our third sum product identity. Now we'll be subtracting 3 from 4. Previous equations we subtract 1 from 2, 1 minus 2, but here we do 4 minus 3. So now we subtract third equation from 4. Then what we will get? Now cos A cos B minus cos A cos B, it will vanish. Now sin A sin B minus sin A sin B, so this will be plus, so these will get added. So it will be 2 sin A sin B. Sin A sin B subtract minus sin A sin B, so minus to minus this will become plus, so it will be sin A sin B plus sin A sin B, which will be 2 sin A sin B equal. Then considering the left hand side, when you subtract cos A minus B minus cos A plus B, we'll have to write the same thing, so just it is cos A minus B minus cos A plus B. Now these are our 4 sum product identities. Now let's see whether we can derive another 4 equations, and we call them also sum product identities, but we call them with a special name called CD equations. Let's see how to derive them using these 4 sum product identities. Now we have proved 4 sum product trigonometric identities. Now we know 2 sin A cos B is sin A plus B plus sin A minus B, 2 cos A sin B is sin A plus B minus sin A minus B, 2 cos A cos B is cos A plus B plus cos A minus B, and 2 sin A sin B is cos A minus B minus cos A plus B. You should see it carefully because this is a bit different compared to the previous 3. Now we are going to derive another 4 sum product trigonometric identities, which we call with a special name called CD equations. Now let's see how to do them. Now considering this A plus B and A minus B, now let's think A plus B is capital C, and let's say this is equation 1, and A minus B is D. This is equation 2. Now by solving these 2 equations, now let's say by 1 plus 2, we get 2A equals C plus D, which is A equals C plus D over 2. Now from 1 minus 2, you get A cancel, so B minus minus B, which will be 2B equals C minus D. B equals C minus D over 2. Now by substituting this A and B to these equations, now we know A plus B is C, A minus B is D, and A will be C plus D over 2 and B will be C minus D over 2. Now from this Roman number 1 equation, we can get A plus B means C and A minus B means D, so we can write basically this one sin C plus sin D is equal to 2 sin A means c plus d over 2, and cos B means c minus d over 2. So this is our first CD equation, and also we can call this another sum product identity since we express a sum in terms of a product. Now from 2 we can get, now A plus B means C, so it is sin C minus sin D equals 2 cos C plus D over 2 sin C minus D over 2. So this is our other CD equation. Now from row number 3, now A plus B is C, A minus B is D, and A is C plus D over 2, and B is C minus D over 2. So we can write it cos C plus cos D equals 2 cos C plus D over 2 cos C minus D over 2. Now last but not least, because this is very special, from row number 4 equation, so A minus B is A minus B is D and A plus B is C. So now we'll have to write this cos D minus cos C is equal to 2 sin C plus D over 2, which means A, and B means C minus D over 2, so it is sin C minus D over 2. But to arrange it in this format, keeping C first, we'll change this, so we can write this cos C minus cos D equals, when we sub these two, we have to put a minus in front, because simply what we are doing is multiplying by minus both sides. So our final trigonometric identity will be minus 2 sin C plus D over 2 sin C minus D over 2. So this is our final sum product trigonometric identity, or we can call it final CD equation. So now afterwards, let's see, using these 8 sum product trigonometric identities we proved, now how to use it practically in trigonometric questions. Alright, let's see how to express this product of trigonometric expressions as a sum or difference of trigonometric expressions. Now, if you remember, we know 2 sin A cos B equals sin A plus B plus sin A minus B. Now, when you consider this 2 sin 5 theta cos 2 theta, this 5 theta represents the letter A and 2 theta represents the letter capital B. So now we can write this as sin A plus B, which is 5 theta plus 2 theta, plus sin A minus B, which is 5 theta minus 2 theta. So we get the sum of trigonometric expressions, which is sin 7 theta plus sin 3 theta. So that's it. Now moving on to the second question, we have 4 cos 6 theta sin 3 theta. Now we can write this 4 cos 6 theta sin 3 theta like 2 times 2 cos 6 theta sin 3 theta. Now we know, now 2 we can open a bracket, and now this is in the format of 2 cos A sin B. So 2 cos A sin B, we can write sin A plus B minus sin A minus B. So now instead of A we have 6 theta, instead of B we have 3 theta. So now we can write 2 cos 6 theta sin 3 theta as sin A plus B, which is 6 theta plus 3 theta, minus sin A minus B, which is sin 6 theta minus 3 theta. So we get our answer. It is when you open the brackets, 2 into sin 9 theta minus 2 into sin 3 theta. Now moving on to the third example. Now we have cos 2 theta cos 4 theta, so we can write this 6 cos 2 theta cos 4 theta as 3 times 2 cos 2 theta cos 4 theta, which we can write now 2 cos 2 theta cos 4 theta, it is in the format of 2 cos A cos B. So we can write cos A plus B plus cos A minus B. Cos A plus B, now this is A and this is B. So cos A plus B is 2 theta plus 4 theta plus A minus B is cos 2 theta minus 4 theta. So it is 3 times cos 6 theta plus 3 times cos 2 theta minus 4 theta is cos minus 2 theta. Now if you remember the quadrant rule which we learned in a previous lesson, if you want I'll put a link about the description or otherwise about this video. Now it is 3 cos 6 theta. Now cos minus theta is cos theta, if you remember. So cos minus 2 theta, it is 3 cos 2 theta. Now moving on to the last example for this part. Now it is now we know it is 2 sin A sin B is cos A minus B minus cos A plus B. So now sin A sin B, now we can write this 8 sin 3 theta sin 5 theta 4 times 2 sin 3 theta sin 5 theta. Now 4 times, now sin 3 theta sin 5 theta. Now 2 sin A sin B is cos A minus B minus cos A plus B. It is cos A minus B. Now 3 theta is A, 5 theta is B. And so it is 3 theta minus 5 theta minus cos A plus B, which is 3 theta plus 5 theta. So where we get 4 into cos 3 theta minus 5 theta is minus 2 theta. So it is cos minus 2 theta minus cos 8 theta. Now we know cos minus theta is cos theta. So it is 4 cos 2 theta minus cos 8 theta. Now let's move on to the other 4 examples which describe how to express sum of trigonometric expressions as a product of trigonometric expressions. Now here what we did was product of trigonometric expressions we express as sum of trigonometric expressions. Now let's see how to express product of trigonometric expressions we express. Now sum of trigonometric expressions, how to express as a product of trigonometric expressions using CD equations. Okay, now consider these 4 examples. Now we have sin 5 theta plus sin 3 theta. We know sin C plus sin D we can write as 2 sin C plus D over 2 cos C minus D over 2. Now this will be C and this will be D. So 2 sin C plus D over 2, which is 5 theta plus 3 theta over 2 cos C minus D over 2, 5 theta minus 3 theta over 2. So we get 2 5 theta plus 3 theta 8 theta, 8 theta divided 2 4 theta. So we get 2 sin 4 theta cos 5 theta minus 3 theta 2 theta, 2 theta divided 2, it is theta. So we express this sum of trigonometric expressions as a product. Now moving into the 6th example. Now it is sin 8 theta minus sin 2 theta. We know it is sin C minus sin D, which is 2 cos C plus D over 2 sin C minus D over 2. So we can write 2 cos C plus D over 2, which is 8 theta plus 2 theta over 2 sin 8 theta minus 2 theta over 2. So we have 8 theta plus 2 theta, 10 theta, divided by 5, divided by 2, it is 5 theta, so it is 2 cos 5 theta. Now 8 theta minus 2 theta is 6 theta, divided by 2, 3 theta, so it is sin 3 theta. Now moving on to the 7th example. So now this is in the format of cos C plus D, cos C plus cos D, so it is 2 cos C plus D over 2 cos C minus D over 2. So we can write 2 cos 5 theta plus 11 theta over 2 cos 5 theta minus 11 theta over 2, which you get 2 cos 5 theta plus 11 theta, 16 theta, divided by 2, it is 8 theta, cos 5 theta minus 11 theta is minus 6 theta, divided by 2, it is minus 3 theta. But we know 2 cos 8 theta cos minus 3 theta is positive cos 3 theta using that quadrant rule, so it is cos 3 theta. Moving on to our last example in this video. So we have cos 8 theta minus cos 12 theta, which is in the form of cos C minus cos D. So we can write as minus 2 sin C plus D over 2, which is 8 theta plus 12 theta over 2, and sin C minus D over 2, which is 8 theta minus 12 theta over 2. So we have minus 2 sin, now this is 20 theta divided by 2, 10 theta, this is minus 4 theta divided by 2, it is sin minus 2 theta. Now we are aware that sin minus theta is minus sin theta, so sin minus 2 theta will be minus sin 2 theta. If you don't know this, you should see my video which I made up on quadrant rule. So now sin minus 2 theta is minus sin 2 theta, minus will be multiplied by this minus, so it will be plus. So we have the final output as 2 sin 10 theta sin 2 sin 10 theta sin 2 theta. I'll rewrite this since it's not so clear. So it is 2 sin 10 theta sin 2 theta. So here we go. We discussed about CD equations, and overall it's all about the lesson is some product identities. So hope you enjoyed it, and see you on another Maths video.